Hi all, let me introduce the second session of binomial distribution using Bernoulli's trials which we have studied in the earlier class. Now what's the meaning of binomial? Bi means two. That is, in Bernoulli's trial, as I had said earlier, there are only two possible outcomes. So likewise in binomial distribution sums, we will be dealing with cases which are having either success or failure. For example, tossing a coin. You either get a head or a tail. Only two possible outcomes. Likewise, throwing a die. Either you get the number 5 or you don't get the number 5. Or answering a true or false question. Either you have a true statement or a false statement. So let us go for the next concept of binomial. Now let's understand binomial distribution formula using Bernoulli's trial. The formula is given as probability of x equal to r is equal to NCR p raised to r q raised to n minus r, where n stands for the number of trials, r stands for the number of success, p stands for the probability of success in each trial, and q is the probability of failure in each trial. We have studied the combination formula in the earlier classes. Let's recall the formula. NCR is equal to n factorial upon n minus r factorial into r factorial. So what's the meaning of factorial? If you remember, 1 factorial is 1, 2 factorial is 1 into 2, 3 factorial is 1 into 2 into 3. Likewise, r factorial is 1 into 2 into 3 etc. up to r. N factorial is 1 into 2 into 3 etc. up to n. And n minus r factorial is 1 into 2 into 3 etc. up to n minus r. This was your combination formula which you have studied in earlier class. So what exactly is the meaning of NCR? From n objects, you are going to select r objects. From 10 students, you select 5 students. Likewise. So let's understand combination formula with suitable examples. 3C0. That is, I have replaced n as 3 and r as 0 in the formula. So that becomes equal to 3 factorial upon 3 minus 0 factorial into 0 factorial. The value of 0 factorial is always 1. So this is equal to 3 factorial upon 3 factorial into 1, which is equal to 1. Next one, 3C1. Again substitute the value of n as 3 and r as 1 in your above formula. So the answer turns out to be 3. Likewise, 3C2. Substitute n is equal to 3 and r is equal to 2 in the above formula. You get it as 3 factorial upon 3 minus 2 factorial into 1 factorial, which is 3. Last one, 3C3. It's 3 factorial upon 3 minus 3 factorial into 3 factorial, which is equal to 1. Please remember, in combination formula, the value of r has to be always less than n or at the most equal to n, because n is total number of objects which you have and r always stands for number of objects that you select from the total. Now let us understand how binomial distribution is derived using the example which I discussed in the earlier class. For example, when you toss a coin thrice, then the sample space S is as follows. So if we look here, the total number of sample points in the sample space is 8, that is 2 power 3. Now let us discuss this given sample space using the table here. We are going to discuss about the probability of getting heads. So x is the random variable which denotes the number of hits. Since, as discussed in the earlier slide, X stands for number of success, so small p stands for probability of success and small q stands for probability of failure. Now let's start with the first column, probability of X equal to 0. That means probability of not getting any hit in all the 3 flips of a coin. So the sample point is T, T and T. So probability of getting a failure in the first flip is Q, and second flip is also Q, and third flip is also Q. So it's Q into Q into Q. That is Q cubed, or it can be written as 1 into p power 0 into q cubed, because anything power 0 is 1. Or we rewrite it as 3c0 p power 0 q power 3 minus 0. Please understand, 3c0 stands for in 3 flips of the coin, no heads were got. So that 3c0 stands for the combinations. Going to the second column, probability of X equal to 1 indicates only one head was got in all the 3 flips of the coin. So the sample points are as given. Let's take the first sample point, HTT. What does it indicate? It indicates in the first flip of the coin, it was a success. Second flip, it was a probability of a failure, and the third also was a probability of failure. So if you take the first sample point, HTT, the probability turns out to be P into Q into Q. Likewise, for the second and third sample points, we get Q into P into Q and Q into Q into P respectively. So it can be either the first sample point or second sample point or the third sample point when probability of X is equal to 1. So that is nothing but sum of all these 3 will be 3pq square. That is 3 into p power 1 into q power 2. So let me represent it in the binomial form. That is 3c1 into p power 1 into q power 3 minus 1. Again, it stands for 3c1 stands for the combinations, p stands for the probability of success, and q stands for the probability of failures. Now going to the third column, probability of X equal to 2. It indicates only 2 heads were got in all the 3 flips of the coin. So the sample points are HHT, THH and HTH. So the probability of getting a head in the first flip is P. Probability of getting a head in the second flip is P. And probability of getting a tail in the third flip of the coin is Q for the first sample point. Likewise, it is Q into P and P into Q into P for the second and third sample points respectively. So the total is equal to 3p square q. That is 3 power 1 into p power 2 into q power 1. That is 3c2 into p square into q power 3 minus 2. Now let us go to the last column, probability of X equal to 3. That is getting all the 3 hits in the 3 flips of the coin. So the sample points is H, H and H. So probability of getting a head in the first flip is P. probability of getting a success in the second flip is P, and probability of getting a success in the third flip of the coin is again P. That is equal to P power 3, or it is 1 into Q power 0 into P power 3, or you can rewrite this as 3C3 P power 3 and Q power 3 minus 3. So now let's generalize this and go for the binomial formula. So now let's generalize the entire table. So when probability of x is equal to 0, we get 3C0 P power 0 Q power 3 minus 0 from the second last row of the table. Similarly, P of x equal to 1 is equal to 3C1 P power 1 Q power 3 minus 1. P of x equal to 2 is 3C2 P squared Q power 3 minus 2. P of x equal to 3 is 3C3 P power 3 Q power 3 minus 3. So we generalize the formula now. If there are n Bernoulli's trials with x number of success, then the remaining n minus x have to be the number of failures. Now if you denote the number of successes R, so looking at this column here, P of x equal to R, where R denotes the number of success. So in every trial, the probability of getting ahead is P. So since P is repeated R times, you will get your P power R. So again in this n trials, the remaining n minus R will denote the number of failures. So the formula of P of x equal to R is NCR P raised to R Q raised to n minus R, where NCR denotes the number of times the head occurs in n number of trials. So probability of x equal to R is the combinations possible into probability of success power R into probability of failure power n minus R. That's the binomial distribution formula. A binomial distribution is usually denoted as B of n comma P, where n stands for number of trials and P stands for the probability of success. We can also represent this as the random variable capital X follows B of NP, where B stands for binomial distribution. Now let's understand binomial distribution using the problems given in the exercise. So exercise 8.1, the first question. A die is thrown 6 times. If getting an odd number of is success, then find the probability of getting sub-question A 5 success, sub-question B at least 5 success, and sub-question C at the most 5 success. Now when a die is thrown once, then the sample space S is given as 1, 2, 3, 4, 5, 6. That is n of S is 6 power 1. A die is thrown twice, then n of S is 6 squared. We have studied that in the earlier classes. If a die is thrown thrice, then n of S is 6 cubed. So if a die is thrown 6 times, then n of S is 6 power 6. It's now impossible to write the entire sample points for the sample space. And that's where we use binomial distribution formula. Again, the sum satisfies all the Bernoulli's trials conditions. The trials are finite because the die is thrown 6 times. Also, the number of outcomes are only 2, getting the odd numbers or not getting the odd numbers. The probability of success remains the same in each and every trial. So here A denotes the event or the number of cases favorable for getting the odd numbers. So the set A will be 1, 3, 5. So number of elements in A is denoted as n of A, which is equal to 3. Number of elements in the sample space S is equal to 6. So therefore probability P of A is n of A upon n of S, which is 3 by 6, that is equal to half. Now since P of A is equal to half, that is probability of success is half, then Q will be equal to 1 minus P, because total probability is always equal to 1. Probability of success plus probability of failure is always equal to 1. So Q is equal to half. So let's go for the first sub question. The probability of getting 5 success is asked. So let's apply the binomial distribution formula. It's given by P of x equal to x equals NCX, P raised to x, Q raised to n minus x from the previous slide. We are going to replace all the values in the formula. So here n is given as 6, x is given as 5, P is half, and Q is also half. Substituting all these values in your binomial distribution formula, we get probability of x equal to 5 as 6c5 into 1 by 2 raised to 5 into 1 by 2 raised to 6 minus 5. That is 6 factorial upon 6 minus 5 factorial into 5 factorial into 1 by 2 raised to 5 into 1 by 2 power 1. So expanding the factorials, the answer turns out to be 6 by 64 or 3 by 32. Now let's study the second sub question, probability of getting at least 5 success. So probability of at least 5 success would mean either you get P of x equal to 5 or P of x equal to 6. So or means it's nothing but plus. So probability of x greater than or equal to 5 is equal to P of x equals 5 plus P of x equal to 6. We have already discussed P of x equals 5 as 3 by 32. So let's go for P of x equal to 6. Now in the binomial formula, P of x equal to x is equal to NCX P raised to x Q raised to n minus x. Here n will be 6, small x will be 6, P is half, and Q is equal to half. So substituting these values in the above formula, probability of x equal to 6 becomes 6c6, 1 by 2 power 6 into 1 by 2 power 6 minus 6. So that is 1 into 1 by 2 power 6 into 1 by 2 power 0, that is 1 by 64. Therefore, probability of x greater than or equal to 5 is equal to P of x equal to 5 plus P of x equal to 6. That is 6 by 64 plus 1 by 64. That is equal to 7 by 64. Now going to the last sub question, probability of getting at the most 5 success. So that means at the most means maximum 5 success. So that will be equal to P of x equal to 0 or P of x equal to 1 or P of x equal to 2 or P of x equal to 3 or P of x equal to 4 or P of x equal to 5. Where P of x equal to 0 means no success, P of x equal to 1 means only 1 success, P of x equal to 2 means 2 success, P of x equal to 3 would mean getting 3 success, P of x equal to 4 would mean getting 4 success. P of x equal to 5 would mean getting 5 success. Since this calculation would be lengthy, so we go for a shortcut method by using the formula. Probability of at most 5 success is also same as 1 minus probability of x equal to 6. Because total probability is always 1, so from the total, remove the probability which is missing in the previous formula. So 1 minus probability of x equal to 6 would mean 1 minus 1 by 64, which is equal to 63 by 64. So hi guys, so we have finished the first sum of binomial distribution. In my next lecture, I will be starting with questions 2, 3, 4 and 5 of the same exercise. Hope you have understood today's session on this topic. Waiting to hear your comments. Thank you guys.